For the given spring mass system, find the displacement y as a function of time. Take g equals to 32 feet per second squared or 384 inches per second squared, or just use 980 centimeter per second squared. The given are, first the weight, which is 40 kilogram, the modulus of the spring, which is 9 kilogram per centimeter, at t equals to 0, y equals to 0, and the initial velocity, which is 28 centimeters per second. In solving spring mass system, we must use this differential equation, which is d squared y over dt squared plus kg over wy equals to 0. By substituting the given values, we have d squared y over dt squared plus 9 times 980 over 40y equals to 0. And actually, the differential equation to be solved in this problem is d squared y over dt squared plus 220.5y equals to 0. To solve these kind of problems, we must first find its characteristic equation. And its characteristic equation is actually in this form. P squared plus 220.5 equals to 0. So by further solving it, we can have the roots 14i and negative 14i. Take note that the roots are complex. And also, when the roots are complex, the complete solution is of this formula. E to the power of negative alpha t times the quantity a cosine beta t plus b sine beta t, where alpha is the real part and beta is the imaginary part. So by replacing the roots to the equation, we may now have e to the power of negative 0t times the quantity a cosine 14t plus b sine 14t, which is equals to a cosine 14t plus b sine 14t. And to find the values of a and b, we must first replace the initials to the equation. So at t equals to 0, y equals to 0. So meaning 0 is just equal to a plus 0, therefore a equals to 0. By replacing the initial velocity condition into the velocity equation, we'll have v equals to 14b cosine 14t. We find that b is equals to 2. And thus, the motion of the weight for t greater than or equals to 0 is described by the equation y equals to 2 sine 14t. Using variation of parameters, obtain a formula for the particular integral of the given equation. The given equation is d cubed minus d squared plus 11d minus 6 times y equals to fx. Since the method of variation of parameters is based on the use of particular solution of the related homogeneous equation, our first step must be to find three independent solutions of the equation. The characteristic equation in this case is d cubed minus d squared plus 11d minus 6. And by inspection, we'll have the roots 1, 3, and 2. Since these values of d are all distinct, the corresponding solutions are y1 equals to e to the power of x, y2 equals to e to the power of 3x, and y3 equals to e to the power of 2x. The Wronskian of the bases e to the power of x, e to the power of 3x, and e to the power of 2x has the value negative 2 times e to the power of 6x. The value of u sub 1, u sub 2, u sub 3 are of this form. By replacing the value of u1, u2, and u3, we'll have now this equation as our formula for the particular integral of the equation earlier. So this is now the final answer.